Howdy do. Okay, guys, so on these, we're doing the same thing that we did in example 6, 7, and 8. But now, if you notice, these have things inside of our parenthesis. Before, we dealt exclusively with things outside of f of x. So 1/2 was outside of f of x, our plus 7 was outside of f of x, and our negative 1 was. But over here, if you see, now we have moved into f of x, which it is slightly different when we're inside of function notation. So let's talk about how that will happen. So you now have our nifty transformation function notation up here. So we'll first state the transformations, which I know you guys are pros at that by now. But after that, we're going to find the equation g of x, which will make f of x do what we just told us to do, which is pretty awesome. Okay, so let's get this show on the road. So first, let's state this transformation. So I have, first of all, something inside of the parenthesis, which the only things inside of our nifty parentheses are the b and the h. Okay, so it has to be a b or an h. And this is multiplying to the x. The only thing up in these parentheses that are multiplying to anything is the b value. Okay, so this is a b value. So b value. And remember, when things are not fractions, they get skinnier. So let's think about it. Which way vertically do we move to get skinnier? Do we move outward or inward? Okay, do we stretch or compress? To get skinnier, we gotta compress. So this will be a horizontal compression, first of all. Horizontal compression by a factor of, remember though, the b value, we have to find the reciprocal of this number. So this number is secretly 4/1. So the reciprocal of that, or if we flip that bad boy upside down, will be 1/4. Okay, so remember you guys, the b value you do have to flip or find the reciprocal, which it makes sense. What this means is it will be horizontally 1/4 of the size that it started out being. Okay, so if we're getting skinnier, okay, remember when it's not a fraction, we get skinnier. So if we horizontally compress, we're getting more narrow. So it makes sense that this is 1/4 of a size horizontally that it started out as. Okay, so remember, b values, you have to find the reciprocal. Everything in the parentheses, you kind of have to do something the opposite with, so watch yourself. Okay, so this is a transformation, but now let's solve for g of x, or find the equation that will make this bad boy get skinnier by 1/4. Let's see what happens. Okay, so remember, we start with g of x in a parenthesis, okay, which f of x, or everything in our parenthesis, is going to go over here, which now we have something new in our parenthesis, the 4x. Okay, so f of 4x is going to go in here, but I need to solve for whatever f of 4x is. Okay, so let's solve for this thing. Okay, I'm going to do some little side work. F of 4x. Okay, so f of x, you guys. Okay, this will be our little scratch work. So f of x is x to the 4th minus 7. But this says to find f of 4x. So originally it was x, but my x has transformed into a 4x. So that means everywhere I see an x, it will transform into a 4x. So if you guys see here, there's an x right here. So that x is going to turn into a 4x. So it's going to look kind of like this. So my x will transform into a 4x, and everything else stays the same. So we have the 4 and the minus 7. The only thing that changed was my x. Okay, which remember you guys, if we have two things multiplied together with an exponent, we raise each number to that exponent. Okay, so that's kind of what all that is. So 4x to the 4th is 4 to the 4th times x to the 4th. Secretly, there's a multiplication symbol in between. Alright, so 4 to the 4th, let's see here. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4, I don't know that one off the top of my head, so I have to do some scratch work. So that would be 256. Okay, so f of 4x, I'm going to write what I get up here, you guys, since we just solved this bad boy. Okay, so f of 4x ended up being 256 x to the 4th, and then minus 7. Okay, guys, and since nothing else is added or subtracted, that would be my answer. So I don't need my parentheses anymore. Okay, so this was my scratch work to figure out what goes in the parentheses. So my final answer for g of x will be 256 x to the 4th minus 7. Okay, so this is the equation that if you graph this first, either on your calculator or on Desmos, and then graph this function will be 1/4 the size that this function will be. So horizontally it'll go in about 1/4, which is pretty amazing. All right, guys, that was amazing and that was incredible. Okay, so now we're going to deal with example 10, which is very similar. Okay, we're dealing with a different value in terms of our transformation, but the process is still the same. So if you want to try example 10, if you're like, I got example 9, it was so obvious, I get it, all right, well, go ahead and pause the video, tackle example 10, and fast forward to the end and see if you get it correctly. All right, guys, so the first step, we need to state the transformation, which I know you guys already know. You're probably like, I know what it is, Miss Long, I know what it is. Well, let's review in case you don't know. Alright, so I have something inside of my parenthesis that is added or subtracted to the x. So the only thing in my parentheses are b and h values, and the only thing with an addition or subtraction symbol with it is my h value. So this is an h value, which remember h, you think the hips, it goes left to right, but you must think the opposite with the h value. Do not forget her, the demon cats are coming for you guys, so watch it. Okay, so the h value moves left to right. Okay, so since it's a minus 1, if we think the opposite, it will be going to the right one space. So this is an h value, and we are going right one space. Or you could say it horizontally translates right one space if you want to be super technical, but I will accept right one space. Alright, so after that, like up here, we got to find g of x, which just is the fun part, so let's get going. Alrighty, so g of x equals, I have my parenthesis, which remember, everything inside of your parenthesis goes in here, which all that is in my parenthesis. So what's going to go in here is everything in the parenthesis, which is f of x minus 1. So I need to find out what f of x minus 1 is. So I'm going to do my little side work for f of x minus 1. Let's figure out what that is. Okay, so f of x, you guys, is, if you see here, x to the 4th minus 7. Okay, so, but now we're going to find f of x minus 4. Alright, guys, so it was f of x, but if you see here, my x has transformed into x minus 4. So that means all my x's are going to transform into x minus 4. Okay, so all that's going to happen is that x will become x minus 4, and then we'll be done. So it'll be x minus 4 to the 4th minus 7. And guys, I'm going to allow you to leave it like that. If you ever have a binomial, which this is a binomial because it has two nifty terms. If you ever have a binomial raised to an exponent, I will let you leave it that way. And the reason why, remember when anything raised to an exponent, that means we're supposed to write it out that many times. So this is secretly like this. X minus 4 times x minus 4 times x minus 4 times x minus 4 and then minus 7. So if I made you multiply all that out, you'd have to distribute all that stuff out, which I'm not going to be mean and I'm not going to make you do that. I'm not testing you on this part on whether or not you can distribute. I just want to know if you can solve using transformations. So again, if you have a binomial, two terms raised to an exponent, you can stop where you are. Okay, now this one was not a binomial. This was a monomial because it only had one term. If you have a monomial, I'm going to make you solve it like we did here. But a binomial, you can stop in your tracks and you'll be done. So this is f of x minus 4. And that's it, you guys. You don't have to go any further. So that is what goes in here. And hold on. Oh, sorry, guys. I don't know why. I guess I was caught up on my exponent. This should have been a 1, not a 4. So just change all these 4s to a 1. I'm sorry. x minus 1. Sorry, I don't know why I got caught up on the 4 for some reason. Guess I was looking at my exponent. Sorry, you guys. So, again, all we did, the x's transformed into x minus 1. That's all that happened. Okay, and again, all these would be x minus 1s technically. So f of x minus 1, x minus 1, x minus 1, and x minus 1. Sorry, guys, about that. Again, I must have fixated on the 4 for some reason, but we got it straight. We got it straight. So, this will be x minus 1 to the 4th power minus 7. Alright guys, and nothing else is out here to add or subtract, so that's simply what g of x is. So g of x is x minus 1 to the 4th power minus 7. And again, this is the equation that would force the original equation to move right one space. So if you graph the original graph, which is x to the 4th minus 7, and then you graph this one, it would cause the original graph, or f of x, to move right one space. And that's it, you guys. Wasn't that a blast?